from a website. Back on your test, put KJ for kilojoules. You see KJ is talking about, that means you have work, okay? Or you might have newtons, that's force, you have meters, that means distance. They might give you two of these, you gotta find the third, okay? Pretty common. But a lot of times, when you push and pull things, you do it at an angle, because an angle, you have to use cosine of the angle. Again, theta is your angle. There's a video right here that explains to you guys, okay? So you guys go to the document my website, click on that, and it'll walk you through. It's a hyperlink, click on that, it'll walk you through it, okay? And this kind of shows you more if you guys pull in the same direction you want to pull, or push the same direction with the object to move, you don't got to push and pull as hard. But the higher the angle away from the direction you want the object to go, the harder you get to pull or push on it. So as far as the angle between the force and displacement gets, so the more the angle gets more 90, so you try to push something this way, but you're pulling straight up on it. At that point, you're not applying any force at all. So you have to go this way if you pull straight up on it. Okay. That's what we're kind of saying right here. The magnitude of work decreases as you angle gets more and more perpendicular to actually where you want the thing to go. This video I'm play very a strawman competition, but I've heard it before. The strawman guys, really popular. They can Sweden and Finland. So I'll pull this up a little bit if I can. So this guy's, everybody does this. Everybody pulls a bus at least once in your life. So he's gonna pull this bus. He's gonna yank it, get the bus moving. He's gonna try to home. He's gonna pull the rope. So notice he's not like straight up and down vertical. He's actually leaning. If you're gonna push or pull something that's really heavy, you better get some angles lean. If you want your direction as parallel as possible with the ground, that way your feet is gonna push the same direction you want your bus to go. Okay, in this case, if you're straight up and down, upright, you pull a lot less force. So the more he leans, the more force he's put into this stuff. His feet, his hands will go in the same direction you want the bus to go. In this case, you would have to take cosine. It's not totally straight. He's probably about a 35-degree angle right there. So in that case, you have to hit the force and his distance. He's pulled the bus. They can measure that very easily. Times his rough angle is at most time to get the actual kilojoules work he did to make that bus move. Okay? You actually could calculate that. Next, or if you push something, this girl here, this looks like a college campus. So just a load. your force go in the same direction you want hit that chair to go. You don't be straight up down trying to push. You can't really push them, but the more you angle yourself, the more you push yourself in an angle, more of the push is push on the ground with that third law. Obstacle force right towards the chair. Okay? So you want that to go in the same direction the chair to go. There you go. Okay? It's a pretty easy concept. You guys done this your whole life when you push both things. You didn't know really the concept behind it. There you go. Okay. Alright. So physics class before. Alright, so as long as the force displacement are in the same direction, the cosine will go in the exact same direction you want that to go, where the angle is going to be 0. Well, the cosine of 0 would be 1. In that case, you just use f times t. You won't have to use a cosine. Okay? The exact same direction, like perfectly parallel. You want the object to go. Okay. There are 4 questions once again about this. I think they're all calculation questions. Okay. There's at least 3. Sometimes there'll be all of them calculations. In this case, probably just, I guess, probably just 3 calculations out of the 4. One's a concept. Now, kinetic and potential energy. There'll be kinetic energy question test and also gravitational potential energy. So this one, gravitational potential energy, is going to be m times g times h. M is your mass. That'll be in kilograms. Your acceleration meters per second. Now, this is g. We on Earth is 9.8 meters per second squared. And your height will always be in meters. Okay. So they'll give you, they won't tell you like this. This is mass. You got to look at the units. Okay, if you got kilograms, you know it's mass. You got m, you got meters, and so on. There are 2 questions deal with this using this equation. One to find height, and one you got to use to find the gravitational potential energy. Okay, or you got to find PE. So one question you got to do find this. Other question you got to find G. That's just basic algebra, guys. You're pretty easy. The key is just knowing how to use the equation, knowing what each unit represents, mg or h or pe. There's one question with mechanical potential energy. If you look at slide 9 of the kinetic potential energy tutorial, slow down, the Ke and Pe tutorial, it'll review that for you. So make sure you look over slide 9 of this tutorial. And then, really working energy. This is a harder question I thought on the test is this right here. So you get an example like this in slide 7. It's going to tell you have a, she has a velocity, this person has a velocity of 50 meters per second and final velocity 25 meters per second. The mass given to you, at least for a car, substitute the values and find, you got to find the actual kinetic energy or the work done to make this car move. So you take the ones bigger, the faster speed, the faster you're going, the more velocity you have, the more work, the more kinetic energy you have. So you can take the 25 and plug it into 1/2 mv squared. There's b down here, and then down below, you can also do the 15 meters per second, made that into kinetic energy as well. And then once you have both those, you subtract. That tells you the work, because work equals the difference in the kinetic energy. Okay. Good. And then here's what gets tricky in the test. On the test, they're going to do this. They're going to say you have an object, for example, you have a car going 54 kilometers in the first hour, and the second hour covers 90 kilometers, so it's going to be going faster, obviously. Okay. Whereas what's the amount of work done by the car over that time? Okay. It gives the mass of the car, same mass we had before. So what you can do, what's tricky about that is units. You got to get this 54 kilometers, 90 kilometers in an hour into meters per second. So all you got to do is convert the 90 kilometers into meters. So 90 kilometers times 1,000, 90,000 meters, and then get your hour into seconds. It's 3,600 seconds in an hour. So 90,000 and 3,600 seconds. Divide it. Okay. You get 25 meters per second. Does it look familiar? Yeah, it does look familiar. If you look up top, same as I use the same numbers basically you guys would use for tutorial. So 25 meters per second. Up here you get 625 when you plug the 25 meters per second into the equation. Okay. I didn't do all that down here, but what you guys would have done, you plug 25 meters per second, 625, then you plug the 54, make the 54,000. How much you guys do on your own if you want the review sheet, and you get 3,600 seconds. We divide the 54,000 by 3,600, you get the 15 we had earlier right here. You get the 15. Then put in 1/2 mv squared, you're gonna get 225. So the work you do to push that, make this 22,000 kilogram car move is going to be, say, number 400. 625 minus 225. That's your work. Okay. But again, it's done the same way as the equation up here, but they'll start you off with this. So from here, look at slide 7 of the tutorial. Just do this, what you see at the top of the page here. Now, also, slide 14, to go to slide 14 now. There are two calculations based on the equations I have over here on the right. It's just mechanical energy equals PE plus KE plus PE. Now I'll convert it over. What you really need to worry about is this equation right here. When you do all the math on it, it comes out this equation. They're going to want you guys to do two calculations. One, you got to find the height, the H, right there. And the other, you got to find P, this one right here. Okay. The key thing is you got to know what G is, which you guys already should know from previous questions. It's 9.8 meters per second squared. You have your height in meters and velocity meters per second. Okay. So you make guys do two calculations using the equation. Don't forget that, slide 14. So if you study guys, you wrote it down someplace, maybe highlight that or circle it. Study guys. Or you got this, you always can look at. And then the mastery test for this has two kind of questions. In fact, you can see in the state on your test for unit 4 have questions like that. So we look at those mastery tests also. There's videos I got linked here. Find how to fly and velocity from height using that equation. And also find the height from the velocity. Okay, you can do something like that both on the test. All right, and don't forget square root. If you're gonna find velocity, do all this. You gotta take the square root of the velocity. That gives you your what we call the second velocity and the new velocity. So just keep that in mind. You gotta take the square root. A lot of kids might forget that. All right. And then the last thing to cover is power and efficiency. You will not have to worry about the efficiency on the test. I thought they would, but when I looked at it, well, if you were to, you do something like this. They got the, I don't know, a wrench. The longer the wrench is, the longer the handle is, you get more force, more input force into the wrench. One. But your output force, when it actually turns a screw or a bolt, will be always less. So if you ever do calculations like this, I don't think it's on the test, I'm pretty sure it's not, but the output force would then be divided by the input force. It's always going to be a small number on top. If your number on top is bigger, you get something wrong. Okay? It doesn't flip around the other way. Okay? And then you multiply by 100 each percentage. If your numerator is always large, I have this right here in the equation. It's very similar to what we have up here. The force of base input and the force out, essentially. It's a very similar kind of equation, but it's not on the test. Okay. I got to learn that because it's going to lead to here. This equation here, P equals FD, and FD is work. Work over time, or FD over time is equal to power. There will be 3 questions about this on the test. Actually, I'm sorry, twice. You have to use equation twice on the test. You know how to manipulate the equation. So if you see watts, you know what's P. You see newtons, you know what's force. If you see an M for meters, that's distance. So you get T, which can be seconds. Okay. Oops. Okay. And then just know how to if they want extra time. Okay. Look for seconds or time. Just replace the P and the T. Be FT over P equals T if you had to replace the equation right there. It's basic algebra. Okay. So know how to use the equation at least twice in the test. There's one question about also machines. Like done math problems to calculate how to do the actual what machines do what. Know the purpose of machines, what they can do. Okay. A pulley, a lever, things like that. Momentum. Momentum will be on the test.